Hello and welcome to Galaxy Advisors. The purpose of this video is to explain how to create a 3D social structure map in Condor. Well, what is a 3D social structure map? Well, on this slide I provided an example of what one looks like. It was taken from a manager's project email for roughly 75 actors in over 175 days. The 3D structure map actually combines three different pieces of information to a composite map. Along the x-axis is time. Condor allows you, hours, minutes, days, months, or years for time. The number of actors is the number of actors involved in your data set. So along the y-axis represents the number of actors, and along the vertical here in Z or Z, the betweenness centrality will range between 0 and 1. So in essence, the social structure map provides a single at a glance of your entire project, combining actors, betweenness centrality, and time into a composite visualization. Now, what have we learned from social structure? Research by Peter Gloor and colleagues have found the following: that social structure actually helps predict creativity and performance of programmers. This was a study of 34 Eclipse open source programmer teams. Bugs, people working on bugs or new features, you might say creative, or used as a proxy for performance and creativity. And what was found that there was an oscillation in temporal communication pattern that helped predict creativity is noticed in the first graph here, where you see kind of in a galaxy, it oscillates back and forth between that and kind of a star group. Then the other type was that if you had a steadiness, either you were always a star or always a galaxy, as indicated in the lower part, then that helped predict a steady performance level. So just by looking at these two social structure graphs, you had an idea of one was involved in a creative activity, oscillating between kind of a star and a galaxy, or if you were just a steady star or a steady galaxy, you were pretty much working on something consistently that helped predicted performance. So a little closer examination here for the pattern of creativity here was that this team was working on new features in the Eclipse, adding new features. They were going back and forth between this kind of galaxy format there in the upper left, which we have the arrows going down. When you have the low depressions in the back part of the plane, that represents low betweenness centrality, so you have more person-to-person or team-to-team communication within the team, versus just someone simply sending out a broadcast message to everyone, which would represent a high betweenness at those very peaks here. So that's how you kind of read this at the time. So in this particular case, you're looking over 300 days and some 40 different programmers involved in creating new features. So at a glance, you can see this oscillation going back and forth just in viewing this graph. In contrast now, patterns of performance, here we had an examples of a steady, well, everything was just pretty much high betweenness, which represents, let's say, the back plane there of that kind of steady yellowish orange group of betweenness centrality, or a few people, or at the lower level another group represented by kind of like that red area, which represented kind of a steady, everyone's talking with everyone. So either prediction, either pattern was correlated with a high amount of, in this case, bug fixes. So what is the social structure map? Again, back to our example of manager's project email, you can kind of look at this map now and get an idea of what was going on, kind of a creative process here at the very beginning, and then towards the end, kind of a more steady performance. Now, this all begs two questions. Well, how do you create a 3D social structure map using your own data? And how can you identify the actors in the 3D social structure map? Well, let's answer both questions. The first question, how do you create a 3D social structure map? Well, several steps. First, you need a database that has timestamps. So open your email, a Twitter or other timestamp database or data sets. Select a desired data set or sets within that database. And then, as you typically have found, you create, view, communication, create a communication view. Now if it's email, we suggest you refine the email addresses. For example, I probably have like 4 or 5 different email addresses, so we want to consolidate me into one person there. And then the next step would be to create view communication, dynamic view of communication. This only works on a dynamic, not a static view. So, and you have a couple choices here when you create a dynamic view of communication. You can create it with history or without history, and it does give you a different mapping results, which I'll explain. And then on the next step is on the map menu. Actually, once you're going to create a map, is click measure and then social structure. Select social structure, and at this point a 3D social structure map will be drawn. We also suggest that on the map menu, again click measure and export the actors between the centrality, so you actually have a spreadsheet of those values by each day or time frame that you selected. So here's an example of social structure, same email data set with history and then without history. You can see on the left hand side with history you have kind of at the very peaks kind of a steady like ruler like aspect. This represents where the between the centrality actually value was carried over from one day to the next, so it represented kind of a steady piece. On the right hand, between the centrality without history was only calculated on those days, so nothing was carried over as a history. And you can see on the right hand side it's much more jaggedy up and down for the between the centrality for a couple members of the team here. So that's really the difference between with history and without history. And so then finally, how can you identify those actors in the 3D social structure map? Like, who are those people with the highest amount of between the centrality or low, and how does that vary over time by individual actor? Well, there's really a couple options. The first one here I'm going to explain is about using the dynamic map. And explore the dynamic map is click view, color by nodes between the centrality or the nodes, so you can actually color an individual node by assigning it a different color. Also click view, show labels names, so you can see who they are, or you can right click on a name and just say show information to select an individual if it's a very crowded or dense map. And then finally click measure between this curve plot, and then you're able to select desired actors. So I've kind of given some screenshots at the bottom to show where those options are. And then finally what you're going to end up with is kind of your dynamic map, and you're going to be able to check the actors' names that you want to see their between this centrality plotted over time. I've hidden the names here purposely just to make it anonymous, but in your data you'll see actually the names of the people and check who you want to see, and then you can actually watch the between the centrality of the individual actors over time. And here in the green portion we see that it was highly variable for one individual in the green, and then in red suddenly some different spikes, and gradually towards the end of the project from day roughly 105 to 175 there was a much more convergence of the between the centrality between these two actors. Now you can identify the actors in the second option, or I call option 2B, is to click the measure export actors between the centrality, where you'll actually have a spreadsheet of the people, and then with a few little modifications to the spreadsheet you'll be able to actually recreate those graphs and pinpoint exactly who is in a spreadsheet. So at the export of actors between the centrality, save the file, open in Excel or your other favorite spreadsheet program. And the column A are going to be the names of the individuals. So select that column A, and we're going to do a text to column parsing. So it'll parse it out across the columns. It's delimited. You can use space identifier. And when I've repeatedly have done this and found that actually the last row is a group between the summary, and it's always off a column after I've done the text to column. So you're going to need to move the entire row of data to the right by one column for that group, at least in the Excel spreadsheet that I've been using. Then step 5 is insert a row at the top and add frame time counter. For example, I've added a 0 to 175 in this particular case I was using of a project manager's map over 175 days. And then you're going to see in the spreadsheet a lot of -1s. The -1s represent that there was nothing. There weren't actually that actor wasn't participating in the context yet, and so I replaced the -1 values with 0 because the next step 7 I'm going to ask you to insert a column to be titled Betweenness Centrality Sum, so you can sum the values going across, so you'll get an aggregate sum for each individual across all those time frames. And then I'm going to ask you to sort the rows from high to low on Betweenness Sum column, and the resulting that will be then will show you who the people have the highest Betweenness centrality, which really represent those people in that far kind of back plane, if you will, when you look at that social structure graph. And then you can use Excel or your other spreadsheet to graph them. So what does it look like when you're done doing all these 9 steps? Well, here's a sample where I've inserted the frame row and I made it from 0 to 175. I replaced the names, actor 1, 2, 3, and so on. Here you'll actually see the names in your email database. I've gone through here, and this represents with history, so you can see at the very beginning that days time frame. This was days 1, 2, 3, and 4, carried over the same for that actor. And then at the far right in column FV you can see the row sum, which was the sum across that 175 days for their actor Betweenness centrality. And I've sorted this so I know actor 1 had the highest Betweenness centrality over this project time period, and so forth. Then I used Excel just simply to do a line graph, and so I can see how this varied. It's also really handy to take out the calendar or along these days or by these dates of what happened during significant events during the project. In this particular project, the project went for a while with not much to activity until the client approved the budget, and then suddenly it started to take off, and you had much more activity involved. So individual actions at the front for a lot of data collection. Then towards the end of the project, there was a much more convergence of the major players where they went back and forth and iterated a solution to having an offsite with approximately 20 people. So having our calendar and knowing those activities, we could associate when this Betweenness centrality varied significantly and what was the activity in the team. So we invite you to explore your social structure and discover patterns of performance, either creativity or other performance. You could also in Condor relate this to either, in some cases, people have customer satisfaction scores. They have other benchmark measures they can correlate between the centrality to those measures. You can explore the text and talk, how the talk was going on at the team at the time. But overall, the social structure map provides that at a glance of the actor's time in between the centrality. We hope you enjoy it.